So today we are going to discuss about network design, which is planning a network with different users, hosts, and services. The objective of this lab is to demonstrate the basics of designing a network, taking into consideration the users, the services, and the locations of the hosts. Now, a slight overview on this. Optimizing the design of a network is a major issue. Simulations are usually used to analyze the conceptual design of the network. Now, the initial conceptual design is usually refined several times until a final decision is made to implement the design. The objective is to have a design that maximizes the network performance, taking into consideration the cost constraints and the required services to be offered to different types of users. Also, various modifications have to be done over the lifetime of the network to ensure maximum performance. So in this lab, we will design a network for a company that has four departments. So as you can see on the right, we have research, e-commerce, engineering, and sales. Now we will utilize a LAN model that allows us to simulate multiple clients and servers in one simulation object. This model dramatically reduces both the uh, amount of configuration work you need to perform and the amount of memory needed to execute the simulation. We will also define a profile that specifies the pattern of applications employed by the users of each department in the company. By the end of this lab, we will be able to study how different design decisions can affect the performance of the network. So the procedure is we create a new project, and yeah, that's easy. Then coming to configurations, okay, so we need three things first. We need application definition, the profile definition, and we need a subnet. Now the application config is used to specify applications that will be used to configure users' profiles. The profile config describes the activity patterns of a user or group of users in terms of the applications used over a period of time. Next, we close the palette after doing that, and then we have configure the services. So I right click on my application definition, and I go to edit attributes, change the name to applications there, and change the application definitions to default, which is here. Now clicking on profile config, I again click on edit attributes, change it, change the name to profile, change the profile config attribute to sample profiles. Now sample profiles contain things like basic profiles like engineer, researcher, e-commerce, customer, salesperson, etc. This will come in handy. Next, we have configure a subnet. So I'll go to my previous scenario. Yeah, simple network. So basically we are going to have two scenarios in this, a simple network and then a busy network. The busy network, we are going to increase the load of some applications. So right now in the simple network, we need to configure a subnet, which is we start off with engineering, then okay, so we start off with engineering. Now in this we go to edit attributes, and here we I'm sorry, so we double click on this, and we have two things here. We have a switch and a LAN. So my switch is connected to a LAN device. This LAN device is basically used to represent a group of client computers, and it also has a server. So it's a LAN device. So basically a switch is connected to a LAN network here. We have a 10 base TLAN cable connecting the switch to the LAN. You're using an Ethernet 16 switch, which if you see it supports up to 16 Ethernet interfaces. It implements the spanning tree algorithm in order to ensure a loop-free network technology. Also, it has a data rate of 10, 100 or 1000 Mbps. Similarly, with the LAN, we can see that the switching speed is default of 5 lakh packets per second, and the number of workstations is 10 by default. Next, we configure this We look at things like so we check the number of workstations which you will find over here, which is 10. Then we go to applications, supported profiles, and then we specify the number of rows to be one, and give it the profile name of an engineer, because we are doing this for engineering subnet, right? So that's it. After this, okay, we are done with so right, we're done with configuring our engineering subnet. Now we can go back to our original workspace. Now similarly, what I did for engineering, I shall do for research, sales, and e-commerce as well. Next i'll Next, I'll configure my servers. So my servers is a subnet here where I have three servers, namely web server, file server, and database server. Now, so now I'm going to configure I have to configure my servers. So you see that I've already done that. I have my servers, I have my switch here, which is uh, which is an Ethernet 16 switch. Then I have three servers, which are Ethernet servers. They have connection speeds of 10, 100, or 1000 Mbps. Now I'm going to configure each one of them. So beginning with web server, I click on edit attributes, go to applications, and go to supported services. Now in here I have, yeah, so in here I have put these four services, which is where I've put web browsing light, I have put web browsing heavy, I've put email light, and I have put telnet session light. Alright, so next I'll configure the file server. Here I'll click on edit attributes again, go to application, service, supported services, and here I have put one light load, two light loads, file transfer and file print. Next I'll go to database server. Now in database server again I have database access light. That done. Parent subnet. Now I've configured all my subnets. Now I'm going to connect them using 100 base T duplex link, which represents an Ethernet connection operating at 100 Mbps. This can be used to connect any combination of the following nodes: station, hub, bridge, switch, LAN nodes. That's it. Yeah. After that, connecting all these. So when you connect all this, you will have an option of like you have to specify, for example, that does the do you want to connect the switches? So you gotta select that switch option. You're gonna connect the engineering switch with the server switch, then the e-commerce switch with the server switch. Likewise for the others as well. After this, save your project. Now we're moving on to the second scenario, which is a busy network. So in the network we just created, we assume that there was no background traffic already in the links. In real networks, the links usually have some existing background traffic. So we will create a duplicate of the simple network scenario, but with background utilization in the 100 base T links. For that, I'm going to click on scenarios, and since I've already made one, I'm going to just go to scenario, next scenario, which is the busy network. Now here, what I have to do is click on these, select all these links, and then click on edit attributes, and go to traffic information, number of rows 00, and here I have set my traffic load in bits per second as 1, and for the server and e-commerce connection I have put it as 1 as well. Now I can show you that. So what I'm showing you is that we are keeping the background utilization to 99%. That means we want the link load to be 99 million bits per second. And since our simulation will last 30 seconds, we will do the following. So that's why I've done this. Next, just save your project and click on OK. Yeah, that's it. We have to choose the statistics. So I'm going to click on choose individual statistics, and I want to see the page response time in seconds for HTTP. So how long will my page take to load, right? How long will my page take to fetch, retrieve? Okay. Next, I will click on OK, and then I will run my simulation. So that's 30 minutes, and that's running. So we have the results with us. Clicking on results browser and clicking on our current project. I'm going to compare the uh, I'm going to compare the page response time for both busy network and my simple network. So as you can see, for the simple network, the page response time is much lower, whereas for busy network, it reaches a peak around the, I would say, 2 minute mark somewhere. So it reaches a peak and then it falls down. Whereas for simple network, it's pretty constant throughout. That shows us that by increasing the load, we have like we've introduced kind of a delay in the page response time. That's why there's such a huge difference between these two graphs. So that completes our experiment on network design. And thanks for watching.